Hello friends, welcome to EC Academy. In this lecture, let us understand ICVS amplifier, which is also known as Transresistance amplifier. ICVS, which is nothing but current controlled voltage source. So current controlled voltage source amplifier, which is also known as Transresistance amplifier. The ICVS amplifier has an input current and output voltage. Hence, we can say it is a perfect current voltage converter because it is having zero input and zero output impedance. As you can see from this figure, the ICVS amplifier consists of current as input and voltage as output. Hence we can say it is a perfect current voltage converter. So it will convert input current to an output voltage. So this ICVS amplifier consists of zero input impedance and zero output impedance. Here we can write the output voltage equation as V out is equal to minus I in, which is input voltage, multiplied with RF, which is feedback resistor, into open loop voltage gain divided by 1 plus open loop voltage gain. So you just need to remember the formula. There is no derivation for this. So output voltage can be given as minus of input current multiplied with feedback resistor, which is multiplied with open loop voltage gain divided by 1 plus open loop voltage gain. Since AVOL, which is open loop voltage gain, will always be greater than 1, so we can approximate the above equation as V out is equal to minus of I in multiplied with RF. Since AVOL is always greater than unity, so we can approximate this equation as minus of input voltage multiplied with feedback resistor. So here negative sign indicates 180 degree phase shift at the output. From this equation we can understand that the output voltage depends on the input current as well as the feedback resistor. So if the input current changes or if the feedback resistor changes, output voltage will also change. So for example, if we keep input current as constant, then if we vary the feedback resistor, output voltage will also vary. So which means the feedback resistor is very much important in ICVS amplifier. For example, if we take RF is equal to 1 kilo ohm and input current as 1 milliampere, then the output voltage will be equal to minus 1 volt. And if we increase RF feedback resistor to 10 kilo ohm and if we keep input current as constant, then output voltage will be equal to minus 10 volt. So from this we understood that even though the input current is constant, if we vary the feedback resistor, output voltage will vary. For ICVS amplifier, the input impedance for a closed loop can be given as closed loop input impedance will be equal to RF divided by 1 plus AVOL. So this is the expression for closed loop input impedance, which can be given as RF divided by 1 plus AVOL. Similarly, the closed loop output impedance can be given as Z out. Closed loop output impedance will be equal to R out divided by 1 plus AVOL. So closed loop output impedance is output resistance of the amplifier divided by 1 plus open loop gain. Here the input current can be written as I in is equal to V in divided by RF. So here input current can be given as input voltage divided by feedback resistor. In these two equations, if the denominator part, which means 1 plus AVOL, is very large, at that case both input impedance and output impedance will be very less, or it will reduce. This is about ICVS amplifier, which is trans resistance amplifier. Hope you have understood the topic. Thank you.